In this lesson, we're going to learn how to use pgBokeh to create realistic depth of field. Now, some of you may be aware of pgBokeh, and what it is it's a plugin that does depth of field, or defocus, and its real claim to fame and why it's popular with studios is that it supports deep, and as far as I'm aware, it's still the only depth of field plugin that supports deep. And it's also extremely physically accurate. Unlike most tools, things like defocus or z-defocus or any of the other techniques you can use to basically just blur an image, it uses algorithms that are designed to actually simulate the way that light travels through a lens and the kind of optical artifacts that you would actually produce, so that you end up with a result that's very photographic, very optically realistic. It tends to be a little slow, and in certain cases it can actually be a little bit unstable, but if you're looking for accuracy and quality, especially if you can take the time to use it, afford the computation time, the results can be really, really beautiful. So let's dive into it. All right, so we've got our shot again. So let's start with making the pgBokeh node. So we've got a bunch of inputs. We'll take a look. Input, kernel, camera, and deep input. Then here additionally we have mats, if we wanted to start putting mats in. Mats would be just the same thing as masks in a normal Nuke node. So to kind of walk you through this, input is going to be your regular input, your beauty pass, your primary image. Something that is important to note is that if your deep data is also in your primary input pipe, it can accept it through this just fine. Otherwise, you'd have to plug it into the deep input if it was just deep by itself. The camera is something that the camera simulation aspect of this plugin is really driven by a Nuke camera. And I'll explain how that works. And then the kernel, if you're not familiar with how image kernels work, basically when you think about bokeh, the actual optical effect, you'll get things like the shape of the iris in a defocused photograph. Well, the shape of that iris is what's referred to in image processing terms as the kernel. And to be more technical, it would be, if you were to try to recreate that in image processing, which we are in this case, it would be referred to as a convolution kernel, because convolution is the type of blurring that we're doing. We're actually blurring it based on the shape of an image, not just averaging pixels together based on how a normal blur node, like a Gaussian blur, just takes neighboring pixels and then averages them together. In the case of a convolution operation, you're actually blurring the image based on a shape, and that shape would be the kernel input. We're not going to use a kernel in this case, but I just thought I'd explain it in case you wanted to try and match something. Because if you have a very specific look in a project that you're working on, and you can see very clearly a certain shape when you have defocused image, and you want the defocused areas of your visual effect shots to match that exactly, then you would definitely try to use a kernel shape based on a reference image from a actual out of focus area from the real lens. Let's start off by plugging this guy in. Input, actually, I'm going to set this to, if we take a quick look, deep image, we still have deep data. Yes, we do. The problem here is I am not merging to deep data, so let's do all. Quick tip is if you do 2 brackets in the label, value, space, and then the name of any knob at all. In this case, we want also merge. So, or let's just grab the deep so it'll be more specific in the label, just deep. If you just hover the cursor over any knob, it will give you the name, bbox, meta input, and this one is also underscore merge. So also underscore merge. So inside of brackets, value, space, also underscore merge. And the result, of course, is we get deep in the label here automatically. And if we change this, it changes. So this is a little bit of nuke TCL or tickle expression that I use all the time because I like to label things, because now I know that at a glance this is not just RGBA, it's also RGBA and deep. So now I can plug in the input here because it has deep data, requires deep input, and we need to now make the camera. Go ahead and load in just like last time, read in our limbic camera. Yes. Okay, so one thing that we're going to do after we hook up this camera is now that we've read in these values, we're actually going to uncheck read from file. So now we're not reading from file anymore, because when we have read from file checked, you can see that these knobs are grayed out. We can't adjust these at all. And we're going to want to, so we're going to want to manipulate things in order to control the plugin. Let's take a look at the result the plugin is giving us. Okay, so in this case, these default settings, we're not really seeing anything happening. So the first reason why is depth channel. The default is depth.z. We don't want to use the depth channel. We're going to use deep. So we'll choose deep.front. Okay, so now it's starting to render this frame. We still don't see much of an issue happening. So let's switch this up. Integrate front pack separately. I want to check this for accuracy. Let's go to lens. Okay, first things first. So now you can see it's still in the default mode where it's basically just faking it. What we want to do is check real-world lens simulation, re-render the frame. Immediately we see a huge difference. So the camera film back that we're rendering with here is full frame still, just 36 millimeters horizontal by 24 millimeters vertical. So let's go ahead, set this to custom, 36, 24 to match the camera. These aren't linked, unfortunately. So now what we're getting with an f-stop value of 1.4 is really, really extreme depth of field. This is not something that I would normally pick. Let's back off a little bit to something like maybe f4. That's a little bit more manageable. Let's take a look at what maybe f8 looks like. Okay, and then f16. So if you're familiar with photography, if you've ever done any photography, you'll know that if you were using a real camera, this is the result you'd expect to get. This is how a real lens would behave. And that's really one of my favorite parts about pgBokeh, is that you can get very realistic results using realistic methods. So you can apply what you know about photography directly to what you know about compositing. Let's just go back down to f4. And what I was doing there, in case you didn't know, is that you can do little operations, division, multiplication, right in a knob. And when you press enter, it will do the math, and the result will actually become the new value. We have now reached the end of the lesson. We learned how to use Peregrine Labs' Bokeh plugin to create realistic depth of field. In the next lesson, we will learn how to set the focal point in pgBokeh.